We all know why soap bubbles are spherical, how capillarity in trees works, how water strider can walk on surface of water. The reason is surface tension, which is defined as the tendency of liquid surfaces to shrink into minimum surface area possible. Let us see the origin of surface tension. Before understanding the actual reason, we answer, what is wrong with the general explanation of surface tension? The explanation goes like this. If we take two molecules, one at the surface and one at the bulk, we can see the force distribution is different for two molecules. For molecule in the bulk, there is perfect balance of forces. For molecule on the surface, there is net force of attraction towards the bulk, which gives rise to surface tension. So, what is wrong with this explanation? Number 1. With this explanation, we may think surface tension force is perpendicular to the interface, but it is parallel to the interface. Number 2. How the molecule at the interface remain in equilibrium, as there is a net force on it. Let us try to address the problem with this explanation. And, we will try to understand the surface tension in its full essence. For this, we should know intermolecular potential function. From this we can conclude the repulsive forces are short-ranged and isotropic, but attractive forces are long-ranged. Keeping this in mind, we proceed further. This picture of forces is incomplete, because this only includes attractive forces. In reality, there are repulsive forces too. Away from the surface, there is perfect balance due to symmetry. Near the interface, the up-down symmetry is broken. To restore the force balance, the repulsive forces must act against the attractive forces. In the direction parallel to the surface, symmetry is present, thus ensuring the force balance. But, the attractive forces need not to be equal to the repulsive forces. In fact, attractive forces are stronger. This is because of the long range of the attractive forces. This gives rise to positive surface tension force. Let us see this in more detail. Our focus is primarily on the x and y direction. We can see, due to the symmetry in the horizontal direction, the attractive forces in x direction remain constant as we go into the bulk. But in y direction, the attractive forces increases, because there are more number of molecules on the other side as compared to previous. So, to compensate for the force balance, the repulsive forces also increases. As repulsive forces are isotropic, this will be the same value of the repulsive force in the x direction. These forces increases up to a limit and remain constant. If we draw attractive and repulsive forces as a function of y, we can see the following distribution. This gradient of repulsive force will present only up to few molecular lengths. If we combine both and draw net force, this will be the distribution. This force only significant on the surface, and this is a tensile force. Hence this is called as surface tension. Conclusion. Surface tension arises due to the pressure anisotropy near the surface. This is due to difference in range over which the attractive and repulsive forces are prominent. That's it for this video. If you like the video, consider subscribing the channel.